Okay, welcome back again, and this is the Chipmaster, and in this video I will be doing another repair on this Dell. I got it as is from the tech, no batteries. Alright, so Dell, seems like a Dell Vostro, I think. It's a Dell Latitude 3330. It looks like a Vostro series also. I didn't know Latitudes like this one. Alright, so as you can see, it's a Dell. And they say that it's not turning on. Alright, so I'm going to head over. Alright, okay, there's no keyboard in it, as you can see. Alright, so I'm going to connect the power switch. It was pulled, I don't know, they pulled it. As I said, I got it as is. Alright, so I'm going to connect the charger. Alright, so the charger is at the back here, port, and I give power. Is it turning on? Yes, it turns on. As you can see, I'm taking some ampere there. But as you can see, there's nothing on the screen. Turns off. Turns off. Right, I'm pressing the button, but I don't know what's happening in terms of the point powered a while ago. So I'm going again. So I remove the power, replug back the power, the charger inside. Fan spins. 640 milliamp, and it's turning off. It's still on. $300, $500. The current is jumping, but let me connect an external keyboard. And there's no caps lock, as you can see. I'm not getting a caps lock, so it's not posting, as you can see. No caps lock there. And I'm now 420 milliamp, 300, and it's jumping back and forth. Alright, so I'm going to take it apart. I think it's already taken apart. Don't see any screws on top of the palm rest there. Oh, we have some back screws here. Again, a little bit more, yeah. Alright, so we have RAM here. Alright, let's try another RAM. It's a Mark Vision DDR DDR3. It's an 8 GB of DDR3 RAM. I have a 4 GB here. Let me try it. Oh, I have a 2 GB I can try. It's a DDR3. That's a regular DDR3 RAM. It's a DDR4. Let's try this one first. If it's a 6th generation, 7th generation, it can work with the Ivy Bridge 3rd generation, DDR3L. Alright, so fan spins, 400 milliamp, 590 milliamp, 580 milliamp, 350, 340. So it's basically the same thing. The current is the current sequence is the same. Nothing has changed. Okay, so I will continue. Let me see if I find a regular DDR3 RAM now instead of an L. Okay, I have a 2 GB here. Let me try on the other slot. Oh, we have some liquid corrosion. I see some liquid corrosion on the slot here. A slight corrosion. Let me try about the first one, because since that one have some slight corrosion there. Alright, so that's 330 milliamp, 400 and 390 milliamp, 200, and I'm still not getting a display. So still doesn't work. Alright, so I'll just continue the disassembly. Oops, sorry. Alright, so the actual power switch is on the board here. As you can see, the switch is here. So it's not plugged in. Let me see. Oh, the hinges is unlocked, screws pulled already. This is the hinges that is broken here. All right. This is the LAN and the audio section. Okay, so this is a SLJ 8C. So this is a Intel Series 7 PCH BD82 HM77. As you know, this is a 3rd gen CPU, which is the Ivy Bridge, right? 3rd generation of the CPU. This is a very old board. This is from 2011. I'll need to get the DC jack out. I think I'll need a data board as well in it. Do I need a data board? Just has some USBs and I'll take it out. Alright, so the board is out. Alright, so I'm just going to connect the data board here and I'll fix the screws. Oh, it's one screw. Two screws. Alright, so this machine was partially disassembled already for me. So there was not much disassembly. So the data board is now secure. Connect the DC jack. Alright, so first I'm going to check all coils and see what the resistance is and the impedance, you can call it. Alright, let's see if I get proper grounding. No. So I don't have to hold the meter out always in my hand here. Alright, there we go. Alright, so we're going to check first standby 5 volts and 3.3 volts. What? I get 10? That's not normal. 3.3 volts. I get 387. Alright, this is the RAM supply coil here. I get 270, 280 if I remove. I get 400. Alright, so that's good. Alright, this should be 1.8 VCC PLL for the internal clock module inside of the PCH. Alright, this is the CPU VCC SA. That's excellent. This is the CPU VCC IO. Excellent. This is the CPU core supply. And this is the integrated graphics. Excellent. So that's all good right there. But this is not normal. I'm getting 10 here. This is 5 volts. That's abnormal. Alright, this is the charger section. Alright, I get 522. Alright, this is 1.05 volts core supply for the PCH right here. And I get 60, 61 there. Right, so all the rails are all good, but 5 volts is not right. Let's plug in the power and see. Alright, so it's on. As you can see, it's taking 300 milliamp there. Fan spins. Let's check if I get in 5 volts. Yes, 5 volts is there. 3.3 volts is there. Yes. 1.35, 1.5 volts. Excellent. 1.8 volts. Excellent, right? This is 1.05 volts. Excellent. Okay, so this is 0.9 volts. 1.05, that's the VCC IO. VCC SA 0.8 or 0.9 volts. Excellent. VCC SA CPU core 0.7 or 0.8 volts. Excellent. And there should be no voltage here at the graphics until the RAM is passed, as you can see here. Right? So no voltage here. So we have two bias strips here. 3.3 volts is there. Yes. 3.3 volts is there. And the next bias, 3.3 volts is also there. Well, I'm getting 5 volts here, but it's a bit low on the resistance. Slow. Alright, let's check if I get in PLT reset. Alright, this is the Wi-Fi. PLT reset. Alright, PLT reset is pin 22. 1, 2, 3, the third pin from the gap. No PLT reset signal. So the CPU is not getting its reset signal. 1, 2, 3. I'm not getting a PLT reset signal, as you can see here. I'm checking the resistance. Alright, the resistance is okay. So I'm not getting a reset signal, as you can see. Let's check if we're getting clock. So normally when the PLT reset signal is not coming, that means the hard start is not completed. The hard start is not completed. Alright, so let's check if we're getting 25 megahertz clock. Alright, so here's the crystal. 0.6 on one side, on the other side 1.5, that's a bit high. Is that normal? 0.7 now. It's off. $1.5. On the next side. Oh, sorry, I'm on resistance. I wasn't on the correct gear. Alright, there we go. So the clock we have 0.5 one side, and the other side I have 0.52. And the other side is 0.5. Alright, so the 25 megahertz clock is okay. Right, but I'm not getting PLT reset signal. No PLT reset signal. So we need to check if we're getting system power okay. Proc power good. The proc power good signal after the CPU gets PCH power okay, right, and A power okay for the Intel active management technology, then it will immediately send the proc power good signal to the CPU. This is 1.05 volts. After the CPU get the proc power good signal, then it will start to decode the SVID command to tell the CPU power supply to start generate its correct voltage and current for the CPU for it to start work, right? So now I'm going to check on the RAM slot to see if the CPU is actually starting. So this is a typical no display, as you can see, right? So let's check on the RAM slot. So I'm checking, this is DDR3, so pin number 202 and pin number 200 and 202. 3.3 volts is there or not? Yes, 3.3 volts is there. 0.6 volts is there. 0.7, sorry, this is DDR3. So half of the voltage, which is the reference voltage. This is the VTT reference. This is the reference voltage. Pin number 1, which is the termination, 0.7 volts. Pin number 1. Excellent. Pin number 1 is 0.7 volts. Right. So we have 3.3 volts on pin 200 and pin 202. Excellent. So let's check to see if the CPU is actually running code. Okay. So I'm going to head over under the microscope. All right. So head into the microscope now. All right, so we're capturing, just testing to make sure that my probes are working. Okay, so we're going to look at pin 202 and pin 200 for clock and data. Right, so this is pin 204, as you can see at the end here. So 202, this is data, and this is pin 200, which is the clock, right? So any one of them I can work with and see if I get some signals there. As you can see, I'm not getting a signal. I'm on the rising edge. Let me set this to the falling edge. Right, you need to capture the signal on the falling edge, on the edge type. Let me check on the screen here. Alright, so I'm falling on the falling edge now. Alright, so let's go again. And I'm not capturing anything, so that indicates that the CPU is not starting because the CPU hasn't got the reset signal. Right, the CPU has not got the PLT reset signal, which is going to go through a conversion circuit to give it 1.05 volts. right? So that indicates that the CPU is not starting. All right, the CPU is not starting, as you can see. So I'm not getting data and clock for the SM bus. So we're not getting PLT reset. So I'll need to check now with a schematic to check to see if I'm getting system power okay. Alright, the CPU is actually getting the proc power good signal. Most times there's no point to check proc power good signal because it's a point-to-point distribution of the signal. Right, some boards it can go through a specific resistor. Right, some boards it can go through a transistor and then controlled by SLPS3. So I will have to check with the schematic. So I'm going to see if I can find a schematic for this board. Alright, so as you can see, the board number is 122751-1. So I'll check to see if I can find a schematic. Okay, so I'm going to check the schematic now. Alright, so that's 122, right, 75-1. Alright, so we have BIOS, we have some files here. We need the BIOS, the schematic, and the board view. Alright, so we have here a board view and we have the schematic. So I'm going to first check for the timing based off this Intel chipset, which is the Intel Series 7 PCH, which is the BD82 HM77. Right, so as you can see here, so it's an HM77 PCH. This indicates that it's the 7th generation of PCH and it's called the Panther Point, right? If it's a 6th generation, it's called Cougar Point, HM65, right? BD82 HM65, which is the SJTNV. This is the SLJ8C PCH. So as you can see, it's the 7th generation, which matches the Ivy Bridge CPU, which is here. As you can see, Ivy Bridge, right? And this is the 3rd generation of Intel CPU. So please bear that in mind. So the timing for this one, we have to find the signal, which is called PROCPWRGD, proc power good. So the proc power good signal is here, which is on the miscellaneous part inside of the CPU section. So this is the CPU, this is the PCH, sorry, right? So and this is going to the PCA, CPU as host power good, right? So we need to check here. As I said, most times it's a point-to-point distribution of the signal. Most times it's not being able to check. So we'll have to just assume that it's there because we don't have a way to use a dummy slot or dummy card to check. So let me check. This is the CPU. We have a resistor here. And this is the CPU section. As you can see, CPU 1B, right? And we have on-core power good signal. When the CPU gets this on-core power good signal, then it will start to decode the SVID section, right? So first we need to check here if we're getting 1.05 volts, right? So we're going to check out this resistor R504. And here is it. So it's on the back side of the board, right? So it's close to this section here. Where is it? Oh, here is it. All right, so these are some decoupling capacitors, and it's right between that resistor there. So let's get under the microscope to see if we can get this 1.05 volt, shall we? All right, so let me all right. Oh, I'm not under the microscope? Oh, I need to zoom out. All right, so we're under the microscope now. And that resistor is right here. Here is it. It says R503. Is it R503? Let me confirm with the schematic. It's R504. So this is R504, right? And this is R518, and this is R503, which is just the pads. It's indicate that the component is not installed, right? Let me get some brighter lights, just in case. 1, 2, 3. 2, 3. Oh, sorry. Alright, so we have brighter lights now. Alright, so we're going back to that section there on the board right here. And this is R503. This resistor here, so it's installed. Right, so it's installed. And let's see if we're getting 1.05 volts there. Alright, so I'm going to plug in the power. Right, so I'm going to give power. Yes, 1.05 volts is there. So the PCH, the CPU, the PCH is actually sending the signal 1.05 volts to the CPU. So the CPU gets the proc power good. So immediately it will start decode the SVID. Alright, so that section is okay. Alright, so the next signal, move this out of the way. Alright, so the next signal we have to check now is system power OK. So that's PCH power OK. So let's check PCH power OK first. PCH, right, underscore PWR, right, OK. Right, so PCH power OK is here. We also need to check A power OK for the Intel active or the ME region, or the active management power OK. So this power OK. So we need system power OK, PCH power OK, right? And yeah, so we need these these three OKs, 1, 2, and 3, right? So A power OK. So this is not installed, right? This is a straight line. PCH power OK is a straight line. So we need to check here for 3.3 volts. So let's find this resistor, and that resistor is on the same side that we're at. Right, so PCH power OK, reset out. So we need to find this signal, and that's close to the keyboard connector. KB. Yes, I think I found it. Let me just confirm it under the. Yes, I found it. Here is it. And that resistor is, and the resistor is R1932, right? R1932, all right, R1935, R1931. But this is the resistor the board view is showing me. R1932, R1931, R2, R1935, R1930. Not seeing it, but the board view is telling me that this is the resistor. R1932. Let me just confirm the board view. Is that it? So we have a resistor here. So it's this one. Yes, it's a straight line. It's a straight line. So instead of the resistor, it's a straight line. Correct. I was wrong. So this is R1932. This is a straight line. Right. So I'm going to check here for 3.3 volts right here at this point. Right. So this is the input point, and it comes to here. Alright, so it comes from here to this via, then to the PCH. So let's check it if we're getting 3.3 volts right here. Yes, 3.3 volts is there, so PCH power OK is good. Right, both sides have 3.3 volts, so PCH power OK is there. Right, so PCH power OK is there. So next I will have to check. So PCH power OK is OK. So my next signal, which is this one, system power OK. And we can check out this resistor here, R1930. And it's pretty much the same spot that we were before. So let's go back there and check at that first gap right here. And that's a resistor which is connected directly. And here is it, this one. This is system power OK. It should be 3.3 volts as well. So it's from here, and the trace go all the way here, and it's going to the PCH. Alright, so let's give power. 3.3 volts is there or not? And I'm not getting 3.3 volts. There we go. No 3.3 volts is here. No system power OK. We're not getting system power OK. Right, the board is on 420 milliamp there. Oh, 3.3 volts is there now. What the? That's a delay. Why is such a long delay? 3.3 volts is there. Wow, that was. Let me go again. Remove the power. I give power again. So the PCH power OK takes roughly 6 seconds or so, or 10 seconds for it to generate system power OK. That's too long. So as you can see, my hand, I'm checking the signal there, and PCH power OK is not there. Hold on. So it's restarting. Alright, so I'm not getting PCH power, system power OK. This is not correct. This is not correct. Right, so I'm getting 300. As you can see, the fan is spinning on and off in a repeated fashion, and I'm not getting anything here. It's gone. Before I was getting it a while ago, I'm not getting it now. So we're not getting system power OK right here. So I'm gonna backtrack now. So after the system power OK, then we'll get PLT reset, right? And the CPU gets its reset signal. So at the moment, we are not getting system power OK. Let me check the resistance to ground to see what the resistance is on PCH power OK. That's good. Resistance is good. No problem there. So this is right here. We checked here. System power OK. System power OK. And it should be going from there to the PCH, as you can see. So it's going to the PCH, but we're not getting system power OK from here. It's not coming. Yeah, I was just checking if I was on the right spot. Yes, I'm on the right spot. So this is what we just checked a while ago. Right. But as I said before, it's going to the EC as well. It's going to the embedded controller here. A path is going to the embedded controller from here, and then so the PCH, this is an empty pad, there's no component here. Oh, so it's been pulled up by system R reset signal, which is, this is what we checked out, PCH power OK. So PCH power OK is sharing this signal with system power OK. Because I checked here and I got 3.3 volts, which is coming to here. It's also going to the CPU, to the EC, to this EC now. And this one is not connected. These two signals are 3 volt always, standby for the PCH. Okay, so that 3.3 volts is not generating. Let me try one more time. Alright, nothing there. I'm getting, this is the PCH power OK, but no 3.3 volts here. No 3.3 volts. So the EC should release this signal. The EC should be sending this signal. And this EC has some pins that are under, similar to a BGA. And there's no, I'm just feeling it to feel if they are getting hot. There's two of them. They're not getting hot. Alright, so this is the one, and this is two. Alright, and these are responsible for system power OK to be issued to the PCH. Alright, so let's backtrack on the schematic now. Let me see the whereabouts of the signal. So as you can see here, this is not installed. Reset out, which is renamed to PCH power OK, we get that 3.3 volts. This system power OK signal is not coming. So let's backtrack to see where this is coming from. Alright, so that's where we're coming from. That's not it. That's not it. Alright, that's the test point. This is a XPD but for Intel debugging. System power OK or debugging as well. Alright, this is our EC, and it's coming from this GPIO pin, which means that it needs to configure the program for this pin to act either as an input or an output, GPIO, general purpose input output, and it's coming from B57 pin, and it's coming from the EC. As you can see, we have an output. See, the arrow indicates it's coming out and it's going to the pages. Alright, so let's continue. This is the timing. See, after CPU, so we checked this already, get 1.05 volts. I'll check system power OK, it's not coming. So after the signal is generated, then we'll get PLT reset, then the CPU will start to communicate through the DMI bus to start the soft start. So this is indicating after the PLT reset, the hard start is complete. The DMI is a soft start, so the PLT reset is not generated, so we are still stuck in the hard start. So this is the timing. So we already checked here already. right? VPP power good, didn't check that one. All right, so we need to check. All these are already coming because this is from behind, right? So we need to check VPP power good. All right, so this is all timing. So the EC is responsible for sending system power okay. So let me see if the signal is generating. VPP power good. And it's not used, as you can see. Its VPP is for the DRAM power okay, which is going to the CPU to tell the CPU that the on-core, the RAM supply section is okay, right? 1.5 volts is going to the RAM controller inside of the CPU, and this VPP power good is coming through an AND gate. So as you can see, 0.75 for the termination and the reference, and PMD RAM power good is coming from the CPU, the RAM power supply chip power good signal, which is ANDed together through the AND gate, and it will release A and B must be high to release Y high, and it will release VPP power good, which is SD RAM power okay, or DRAM power good. So this is coming to the CPU. So DRAM, right? PWRGD. DRAM power good. PM DRAM power good. So no other pages. All right, so SYS underscore PWR OK. So the DRAM power good section is here. See, DRAM power OK. Right, DRAM power OK is coming out of the PCH and it's going to the CPU. Right. So this is 1.5 volts. So if we check here, so that's on the other side, right beside the PCH here. Turn the board around. All right, so that's one. So from this resistor network here, we have 1, 2. That's the second one. Right, and that's a straight line, as you can see on the schematic. The schematic here, as you can see, it's just a line, so it's not the actual component. So please bear that in mind. And here is it. It's right here. All right, so I'm going to give power. Zero 0.5. It's confirming. Yes, it's the second one. 0.5 there. 3.3. Oh, here it is now. So 3.3 volts, so that's good. So the PCH is releasing DRAM power okay and sending it to the CPU. Right, so it tells the CPU that the RAM supply and the termination and the reference supply is all good. So we're getting 3.3 volts on both sides there. So System power OK is our problem. So we're getting all rails, all signals up to system power OK. Alright, and system power OK is generated from here, as we all know it from before, right here. Alright. So the PCH need this signal to send PLT reset. Alright, so I give power. So the EC is not sending it. I only see this signal came once. I only see this signal came once. So there we go. It's not coming. No system power OK. Alright, so first let me see if this on the 5 volt and 3.3 volt section, as I said before, even though it is shorted, I got a low resistance, it still generates 5 volts. See? So I'm measuring this coil here. This is 5 volts, and I'm getting, it's always low, which is abnormal. And 3.3 volt section is good. This is the PWM IC. It is TPS 51225, a very classic chip back in the days, in this era. Alright, so I'm going to go to the schematic and I'm going to check for that section, and it's right here. Alright, so we need to check the power good. See, 5 volts and 3.3 volts power good. Let's check that pin. Let's check PR4119. If we're getting 3.3 volts there. Alright, so PR4119. And that's it. Let's check if we're getting 3.3 volts. Yes. Yes, 3.3 volts is there. So it's good. Alright, so all is well there. And this is a pull up. If we go to the schematic, right, and the power good, here it is, pin number 7. And it's pulled up PR4119 100K, and this is sent to the EC. Yes, so it's sent to the EC. So could it be that our EC is bad? Right, so PM power OK. Let me check if this is OK as well. Right, so we can check here SLPA to turn on Intel Active Management Technology. 2 switches high, the pin number 4 will be high. Alright, so I'm going to check this AND gate, A and B, U1902, and it's beside the PCH there. Let me see which side. it's below the PCH. Is it installed? Yes. So let's check that AND gate. Oh, I wasn't on it. Alright, so as I said before, we have A power OK, PM power OK. SLPA and SLPM power OK is going to be ANDed together. This is an AND gate, so 2 A and B must be high, and it will output Y4 high. Alright, this is the supply, and number 3 is grounded. So PM power OK, which is going to be generated from the EC, as you can see here. PM power OK is coming from our EC, right, and this is the EC, right, and the EC, as you can see, is MEC 5055, and we need to find PM power OK, PMA power OK for the Intel Active Management Technology, right, and this, as you can see, it's 1.05. Oops, no. Okay, so this 1.05 volts power good is coming in, and once it gets that in, it will immediately output this power OK signal, and it is here. So we are checking here, U1902, and it's here, below the PCH here. So we're going to check here if we are getting 3.3 volts. And here it is. Sandy and sun. Alright, let me move the power. Alright, get my probe ready. Alright, so here we go. So pin number 1. This is SLPA 3.3 volts, right? Alright, pin number 2. A power OK. Excellent. Pin number 4, output. So all is well. And the supply. So the AND gate is working and all the signal is there. Alright, so the EC is most likely not working. So the EC should be sending 1.05. System power OK. It's not coming out. Alright, I'm gonna pause. Okay, so I have here a donor board that I found. Alright, so this is another latitude here with the 2 ECs. So this is the one I'm going to replace. I'm going to take this one from this one and I'm going to replace it with this one. Alright, so I'm going to reball it. As you can see, I have a stencil here for it to reball the pins and then solder. So let's do this. So I'm going to remove the one from the donor board and prepare it. Alright, so as you can see, the same part number as MEC, right, 504. If you can see, so it's ECE 5048LXY, and this is my board that I'm repairing here. As you can see, it's so it's ECE 5048LXY as well. I don't know if I can get this thing to pick up under the microscope. Oh, there we go. That's it. So we have ECE 504B8, sorry, LZY. So it's the same thing. So I'm going to remove it. And see if I can fix. Just confirming something. Alright, so I'm going to start. Right, increase the temperature. I want 420 degrees. Alright, so that's now removed. Alright, so I'm going to prepare and reball. Alright, so here we go. 1, 2, 3. Alright, so I'm just cleaning the pads there. Alright, there we go. Alright. Cleansing. Alright, so we are cleaning that part now, and that should be done in a few. Alright, so I'm going to, as you can see here is a stencil. So I'm lining up. But there we go. So we have all pads now lined up. So I will now use solder paste. Let me get the paste flux. Solder paste. Alright, so the paste flux. Solder paste, sorry. Keeping calling it paste flux. Alright, so I'll just wet and dry with the napkin here. Okay, so I will now set my temperature to 300 degrees and flow. All right, there we go. Okay, so it's now all flowed. Remember, this is similar to a BGA, so it should be treated as such because there are these pins that are under. We can't check these pins, right? So these pins are not able to access, only these outer pins here. So it's similar to somewhat of a BGA. So this is why there's a stencil for it. So you have to make sure that all the pads are evenly distributed with solder, or else it can cause a problem when you're soldering and the signal cannot be generated or released from the chip. So please bear all of that in mind. I'm now an hour in the video, so I'll have to remove this one now from the target board. So I'll remove it. This is the chip that's responsible for releasing P system power OK. So I'm replacing, I'm going to add some flux now so I can remove it. Alright, let's go. So I'm going back to 420 degrees. Alright, there we go. Alright, so that's removed. Alright, so I'm now adding flux to tin the pads and tinning with leaded solder. It's gonna rain. Alright, so I'll just move this little excess from the ground pad here. So that's because I'm not going to press on the chip, so I'm just going to let surface tension do its work. So I'll let the surface tension do its job, right? So now I'm going to just clean this old flux and then add fresh flux. And then now I'll add the fresh flux and just rub it, spread it with my finger here. Make sure that all the flux are spread on all pads. And then it's time for the soldering. Alright, so pin 1 is here. Alright, so pin 1 is here. So this is pin 1. Pin 1 to pin 1. And I will hold in place while soldering. So I'm going to set my temperature now to 390 degrees. I don't need. And I will do this and as I said before, I will let surface tension do the rest of the job. Turning down my air. It's already doing its job now. As you can see, the chip is now snapped in place. Alright, so the job is done there. Alright, so I will now allow it to cool. And I'm going to give power now. Alright, so I'm going to give power. $400, 446. Let me see if we are getting that system power okay here. And it's still not there. It's the same fault. So it's not this the EC. It's doing the same thing. It's off. It's off. Oh, it's plugged out. Alright, so it's not the EC. Not getting 3.3 volts as you can see. And the light is amber in the same way and doing the same exact thing. Wow, this one is tough. Alright, still not getting 3.3 volts. So because of time, I will have to pause and then do more further checks, and then I will get back to you and explain how I arrived at the issue, at the fault. Okay, so that 5 volt area there that is shorted, so I'm just curious to see why is this resistance so low at this coil. Right, so as I see, I've soldered the wire here on one side of the coil. I lifted, and the short is on the rear stage or the back end of the coil. So I'm going to see if I can capture what's going on here. So I'm going to give power. I'm giving roughly 4.5 volts, and I'm getting 1 amp there. Alright, so I'm getting 1 amp. Let's see what's getting hot. Let's go around. The board is a bit big. Let me just unscrew this data board here so I can get more room. Since I replaced the EC and there's no change, so I decided to check here for this low resistance to see what's getting hot, and hopefully that should tell me that is causing the problem there, because right now it's almost impossible to figure that problem out. So I replace the EC, still nothing changed, same phenomenon. Alright, so I'm going to look under the PCH, checking from the PCH section here, see if I get anything hot. Alright, so I'm getting 1.2 amp. Oh, something is getting hot right here. Let's see what it is. Let's see what it is. It's 43 degrees. Let's see. Oh, it's that chip. That's a PCH chip in one. I don't have that chip though. Hold on. Sorry. Okay, so but that chip actually works because it's actually generating the voltage, and that is the CPU core supply. So it's right there. Cursor is pointing to it right there. Let me check the other side of the board. And there's nothing there. But the voltage is actually generated. I don't think I have that chip either. Okay, so I think I found the problem. So that regulator there that is getting hot, it's actually generating the CPU core supply, and upon checking, the voltage is not stable for the CPU. So most likely the CPU power supply chip is not generating the VRM power good. So this is the core supply. If you take a look, it's now 0.7 volts. And then I see it drop to 4.5, 4.9 volts, which is abnormal. See? It drops to 4.8 volts, 0.4 volts, sorry. Right? Then the fan spins in a loop, and it's now stuck at 0.48 volts. That's too low for the CPU core. Right? So this VRM, this DRM, you see? Now it's 0.7 volts. And then it's going in a loop. It's doing this in a cycle. So it's 0.7 volts and it drops to 0.4 volts. Let's see. So it's now 0.8 volts, 0.7. And that's now it's just now at 0.7 volts. I see it drop to that voltage once. Alright, let me see if the CPU power supply chip is releasing CPU VRM power good. So the CPU power supply chip is here. This one? Yes. That's the charging chip. Sorry, that's the charger I see. Oh, it's on this side. Here's the CPU core supply chip. So it's PU4201. Alright, so VR ready. We have VR ready 1, we have VR ready 2. VR ready 1 is for the VCC SA, VR ready 2 is for the CPU core. Alright, so we have core phases. So we have select 4, we have VR ready 1, VR ready 2, select 6. So VR ready. So we're getting the core voltages, which is here, this is for the AXG, so the integrated graphics. This is the CPU core. And this is the sensing. V core sense positive, V core sense negative. This is the feedback for the CPU power supply, and this is for the feedback for the integrated graphics. So we need to check this one, PWM1. We have 2 and 3. PWM V core. Okay, so the output side is here. So this one is for the V core. This is one that we're checking, and it's reading low, so it has a fault. So we have the PWM, we have the supply, and we have the boost and upper VDDH upper MOSFET, VSS lower MOSFET ground. This is connected to 5 volts. This is for internal operation. .8 volts. V-core PH. This is for the sensing. So this is a chip that is giving us a low reading. So this phase is PWM1. Power core VX1. So let's check. Power good. VR ready. We have VR ready 1. We have VR ready 2. So let's check for VR ready 1. And that's coming to this resistor here, and this is 3.3 volt run. All right. And that's pin 47. So 3.3 volts on both of these. Let's check. Alright, so here are the 2 resistors. Alright, no short there. See? And I'm not getting 3.3 volts. So I found the problem. I have found the problem. And the CPU VRM, this is PWM1, this is PWM2, VCC SA, and this is the core power good. VCC SA power good is not generating as well. Alright, so this should be VCC SA, 1.05 volts. So let's check on the schematic. Alright, so I'm going to type in VCC SA. So VCC SA, power OK. Yes, see it here. Here is it. VCC SA, that's PL4801. And that's that coil here. Looking at it from this angle. Oh, it's over here. Right here. So I was checking the correct spot. That's the spot. Oh. So the PCH is here. Okay, so this is VCC SA. This is VCC SA coil 1.05. Alright, the voltage is fluctuating as you can see there. Let's see the core. It's now 0.7, 0.8, 0.49. As you can see, that's abnormal. And then the fan spins again and it increases the voltage. And that's abnormal. So the voltage is not generating properly, as you can see. So I found the problem. VCC SA is now 0.8. Fan spins fast and drops its RPM, and then the voltage changes. See, it drops and then goes. So this is indicating to me that the PWM IC here, our fault is here. So I'm not getting 3.3 volts here. As you can see, the latch is closed. I'm not getting 3.3 volts pull up on either side. Let me check the resistance. All good. All good. Alright, so I don't have this chip at the moment. I'll have to see if I can find on a donor board. I'll have to pause and see what I can find. Alright, so I'm gonna join the V-core power board resistor together and see if I'm gonna get CPU power okay, system power okay rather. So I'm just gonna join a wire on this. There is it. Let's join in a wire there. Alright. So I'm going to check if I'm going to get system power okay here. Remember this spot? Right here. At this point. So I'm going to give power. Yes, and I now get system power okay. So that indicates to me that definitely the CPU core not generating correctly. So since I joined the wire, now I get system power okay. Right, let's see if I get in PLT reset signal. PLT reset, where is that pointer? Is it on the data board? Oh, I'll have to connect the data board. So I jumped the wire there, and as you can see, I got system power okay now. So that indicates to me that that was my fault from all this time, and I wasn't taking proper notice that that was the actual culprit. That PWM drive chip there is causing the CPU to regenerate the voltage each time, which is the V-boot voltage, and the CPU is actually sending the correct voltage communication to the SVID to communicate with the CPU power supply chips. But each time it tries to communicate the voltage, this PWM chip, this DRMOS chip here cannot keep up with the voltage, so it keeps on dropping the voltage, so the CPU cannot start, and it's causing the system power okay not to work, and no PLT reset. So I'm going to check pin number 22 on the Wi-Fi slot, on the Wi-Fi card slot. PLT reset signal. So it's right here. Let's see if we're getting 3.3 volts now. Yes, PLT reset is there now, 3.3 volts. Let's check if we are getting the CPU to read RAM now. So I'm going to go to the oscilloscope. Let me connect the oscilloscope now. Alright, so I'm now connected the oscilloscope, so I'm going back under the microscope to check pin number 202 and pin number 204 if I'm getting any wave. Alright, so I give power. And there's no signal, so the CPU is not started because its correct voltage is not generated. As you can see, I'm on rising edge. Let me change this back to, I'm on falling edge. Okay, so all the settings are okay, but the CPU is not starting, so I'll have to replace this chip. So there's no signal, as you can see there, no data, no clock. No data, no clock. CPU is not starting. So as you can see there, I found the problem. So I'll have to order that DRMOS chip and replace it, and the board should be fixed because the voltage is not stable. So understanding the timing, as you can see, I was going by the timing, but I saw that short circuit, but I overlooked it because the voltage were generated, but I didn't know that the voltage were fluctuating on the CPU core. So the CPU core supply need to get that VR ready signal for both the VCC SA signal voltage and the core supply for the CPU. For the CPU power supply to generate the VR ready signal, which is pulled up by a 3.3 volt run, and then the EC gets that power good signal. Once the EC get that power good signal, then it will send system power OK and PLT reset, and the CPU gets its reset signal. But at the time now, the CPU cannot generate the SVID command, and it's not getting the core supply, so it cannot start the DMI communication between the CPU and the PCH. So I will replace this chip. As you can see, the board is practically repaired now, right? So I will just replace that DRMOS chip, and the board should be up and running, right? And that concludes the video for today. So I hope you learned something. It was a bit tough. That was a tough one to a point, but I just overlooked that short circuit there on the 5 volt always line, and it was that DRMOS chip that was causing the voltage of the CPU core to be fluctuating and causing it not to release the VRM power good and for the PCH to get the system power OK signal. So I hope you learned again, and I hope you like and subscribe, and tell me what you think about this video in the comments, and in the next video I will definitely repair something for you again. Okay, bye.